Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on higher order differential equation type 4. So this is our question and we need to find the solution of this problem. Before that, as you can see in type 1, we have e raised to x. In type 2, we have sine or cos ax plus b. In type 3, we have x equal to x raised to m. And in type 4, we have e raised to ax into v. But this part matches with e raised to ax into v, where v is some function of x, so sine 2x will be v. But we do not have any type of 2 raised to x. So this part is not there in our type. So what we are going to do, we are going to simplify this part. We know that e raised to log of something is that something. So inverse is also true. That is, if we have something like 3, we can write it as e raised to log of 3. Similarly, we are going to write here as 8 into e raised to 3x sine 2x plus, instead of 2x, we are going to write e raised to log of 2 raised to x. We are following this thing. After this, we know that whenever we have log of, in this case it is 2 raised to x, so this will be equal to x log of 2. So we are going to apply this in this part. We will get plus e raised to, I am going to take this x here, so it will become x log of 2. So this is now our new equation. So the solution of this problem is given by y equal to yc plus yp. First we will concentrate on yc. To find the value of yc, we need an auxiliary equation, and auxiliary equation is nothing but this equal to 0. So d square minus 6d plus 13 equal to 0. So this is the quadratic equation, and the roots of the quadratic equation is given by minus b plus minus root of b square minus 4ac upon 2a. So in our case, b is minus 6, so minus into minus 6 plus minus root of b square, so 36 minus 4, a is 1 and c is 13 upon 2a. So if we solve this, we will get plus 6 plus minus root of 36 minus 4 into 13 is nothing but 52. So 36 minus 52 is nothing but minus 16 upon 2. We cannot take the root of negative number, so this root of minus 16 will be complex. So this is nothing but 6 plus minus I, and root of 16 is 4 upon 2. If I divide by 2, I will get 3 plus or minus I into 2. So this is our roots of this auxiliary equation. This is the complex root, which is equivalent to alpha plus or minus I times beta. Okay. So yc in this case is given by e raised to alpha x into c1 cos of beta x plus c2 sine of beta x. In our case, alpha is 3 and beta is 2. So we get e raised to 3x into c1 cos of beta is 2. So 2x plus c2 sine of 2x. So this is our yc. After finding yc, we will calculate yp. And the generalized formula for yp is nothing but 1 upon fd into x. In our case, fd is d square minus 6d plus 13 into x. X we have modified as 8 into e raised to 3x sine 2x plus e raised to log of 2 into x. So now I am going to separate these two terms. We will get 8 into e raised to 3x into sine 2x upon d square minus 6d plus 13 plus 1 upon d square minus 6d plus 13 into e raised to log of 2 into x. First we will solve this part. So this part is nothing but equivalent to 1 upon fd e raised to ax. In our case, a is nothing but log of 2. This is of the type 1, so whenever we have type 1, we replace d by a. In this case, we are going to replace d by log of 2. So this equation will become e raised to log of 2 into x will remain as it is, and d will be replaced by log 2. So this will become log 2 square minus 6 into log 2 plus 13. and this numerator is nothing but equivalent to 2 raised to x. So we are going to again write that. So as you can see, why we need e raised to log of 2x, so that we can apply the formula of type 1. That's why we wrote e raised to log 2x instead of 2x, and while writing the final answer we will write 2 raised to x. Anything will do. So in this case, as you can see, this equation is of the form 1 upon fd into e raised to ax into v, where v is some function of x. So this is of the type 4,